Yeah, I can take a look at the specific thing it's saying. Okay, I'm just going to do that again. Well, let's make sure, let's verify that that actually solved the problem. Okay, it did. Um, right, so again, where you go to solve, you're getting all kinds of errors right out of the box. You shouldn't be. So go to File, Build Settings, Player Settings, and then over here you want to change to the later version of, what, scripting runtime version? Was this the thing? Yeah. Yeah, from 3.5 to 4.x. All right, so that did it for me. So hopefully it'll do it for you guys as well. Sorry about that. That's annoying. All right, good. So let's take a look. Oh, right, I wanted to actually run this thing. Let me run it first. All right, so if you grab this guy, you see you can hook them. You can hook both of them. If I hook him and click on the other side of the wall, both of them should just plow through. As soon as they get anywhere close so they can see the other guy, it's like in the middle of the wall, probably there's just a molecule of him coming out the other side of the wall. They can see one another, and actually what's going on is once they're through the outer skin of the wall, they can see the other guy. So, all right, so there we go. Okay, all right, so now let's take a look at the code. So what was flagged for you here in the specification was command interface.cs. So command interface is the code that handles hooking the guys and giving them commands. And then entity, so entity is just a term of art for any individual thing in your simulation. Okay, in our case, it's like one individual combatant. In some sims, it would be like a whole company worth of people, right? Or a battleship, okay? Those are the main files to look at, and to be honest, there aren't a lot more there. Okay, now this thing wanted me to reload. Okay. All right. All right, so let's start with the command interface, and I'll just talk you through what's going on here. So obviously, you're still going to use the command interface, right? Because I still want to be able to command guys by hooking them and then clicking down, right? So here we go. So the command interface, it has that little green thing that it puts over the units. That's called the cursor. Okay. Let me actually show you for those of you who are newer to Unity. When you make a variable public, you have a property of an object okay. Well, first things first. So normal scripts inherit from mono behavior. Okay. And when you have a mono behavior type object and you have a public field, then it does something that's kind of nice. This is one of the things Unity is known for. It makes it available. So this script holder is what actually has it. It makes it visible in this inspector window over here. And what you can do is this cursor is an actual object. Here it is. It's just floating off in space over here. You can actually take the object and you can drag it right into its slot there just to connect. Basically, give the script a way to connect to that object. So shouldn't be too amazing to people with experience like in this room that you can do that, but it does sometimes make things easier, and people love to do stuff without coding when they can. All right, so when a mono behavior runs, right, the first thing that happens when it's born is any start or awake callbacks, if they're defined, those get run. Right? So the thing about the Unity game engine model is that almost everything you're writing are callbacks. You don't control the main flow of the program. The main control is Unity's. What you do is you create some behaviors and you say, okay, well, when you first instantiate this object, I want this to happen. Okay, then you put that in your start call. Oh, every time you go and update the simulation, I want some other stuff to happen. Okay, that would go in an update or possibly a fixed update call. So fixed updates happen more rapidly. It's used for physics and the most mission critical stuff. And updates happen still, maybe, hopefully at least, multiple times a second, right? 30 times a second, 60 times a second. So they're pretty fast as well. All right, the first thing you see here is this is the way in Unity you go and ask if a mouse button is down. So the 0 button is the left button. So whenever you click down left, this code is going to run in the next frame that gets generated the next time an update callback happens. So on average, like 1/30th to 1/60th of a second from when you touch the mouse button. It's like almost no time this will run. Okay, and then what happens? Well, a ray is cast. So ray casting is critical for, the A-Star Pathfinding project is doing all kinds of ray casting to define the waypoint graph and figure out where obstacles are. Okay, and we need to do ray casting too. We'll be doing plenty of that. Okay, so what is ray casting? It's just we have a couple points. We want to know if that line in between those points intersects any solid objects. Right? Basically, we want to know if we can see from one point to another. Sometimes we use that as a surrogate for deciding whether we can move between those 2 points. That's a little sloppy, but it's done. Okay, so you set up some stuff. Okay, so in fact, to build this ray, so there's a special nice helper function here where you give the camera is your eye point in Unity. So the camera has a method, screen point to ray, where you can give it the mouse position and it figures out the ray that basically goes right from when you click on the mouse on that straight line right into the scene. Okay? That's a well-defined line. So that's the ray we want to test. This is how we set it up. This is how we actually go and cast the ray and determine whether any hits have occurred. So in C#, this out keyword here just indicates that that variable is filled by the function that we're calling. And so we're going to use that on the backside after the function runs. So like in Java, I think they're not so picky about that. At least they weren't when I did a lot of Java. Okay, so, right. So the first thing we do here, so if you wanted to, again, so Unity also has very good API documentation, right? And you see there's a lot of things here. Hopefully, and actually I'm quite sure, you're not going to need to dig down very deeply for most of these things. A few words from me are probably enough and you get the general idea, but sometimes not, right? And if you want to go looking for more information, if you go to the main Unity website, they have API documentation there, which is very, well, definitely on the good side. All right. So when you click down, it constructs a ray into your scene, okay? And if you actually hit a thing, a cube, a tank, one of my little funny guys with little long beaks on them, anything that's in the scene, you can extract that then from this hit argument to the function via hit.transform. So a transform is just describes where a thing is, a position and an orientation. So if there was a hit, where is the position orientation of the hit? Okay, but that position and orientation is a position and orientation of a thing, right? The thing that we actually hit. So we, that's a little bit of a weird invocation, but that's what it is. What it is. So that's one valid way to get the object that you were hit. Again, game objects in Unity are like almost anything that you place in the scene is a game object. Okay, this is how you debug. You do debug logging. So this is very handy. So those debug logs, if you want to actually see your log, anything you debug log will come up at the bottom of the screen, but it could instantly be replaced by the next message or some error message, right? So Control-Shift-C is what I use to go and get the console to pop up, and here you can see there's some error messages with the red exclamations, but all these other messages, somebody shooting someone else, those are all debug.log messages in my code. If you look at any of these, you can go find these, and they'll be there. All right. Good. So now we know we hit something. Okay, but there's a couple of things that we care about hitting in particular. Okay? One would be any of the guys we command. Okay, so this is the test to see if any of the things we clicked on is one of the guys we command. So it's taking the object that was hit, and it has a command tag, a compare tag method, and it's checking to see if it's tagged as blue force. Okay, what the heck is the tag thing? Okay, so if you come up here and you grab any object at all, like in particular, here's one of my actual blue force guys, and you look at the inspector window, you see up here, it has there's a way to set tags for it. And I've preset all the guys you can control to be blue force. Now, if I click on the ground instead, you see the ground is untagged. Okay? The other thing up here which is useful, I'll talk about that next hour a little bit, is the layer, because that's used by the A-star code, but we'll talk about that later. Okay, so that's what that tag thing is about. So this checks if it's a blue force guy. Now the other thing that is interesting to click on, once you hook a guy, you want to click and say, okay, you go to this hill. You're going to click on the terrain. So I also care if I've clicked on the terrain, and here I'm actually using the name of the object, and I'm testing whether the object is named terrain. Now, how do you tell the name of an object? Okay, that's the thing that's actually coming up in the hierarchy right here. Right? So here it is, comes up over here in the inspector as well. All right. Now, if it is a blue force guy that I clicked, then he becomes a selected object. You see selected is a local property for me. Game object selected. Okay, so now I have that tells me that an object has been selected. If selected is null, I know there is no object selected. Okay, and then what I'm doing here is, okay, I'm setting that cursor to have as a parent object the blue guy that I hooked, and that's what moves him and locks him to the blue guy. So then as the blue guy moves around, that green thing just floats over his head, showing me that he's a selected guy. Okay, when you click on the terrain, okay, what happens is we take the selected guy, okay, all right, so now it's a little bit more Unity magic here, right? So Unity game objects are not monolithic things. They're broken down in a very fine-grained way, often into a lot of different components. And this is how you ask for a particular component. So for the terrain, okay, hang on, no, this is not the terrain. This is the terrain. Selected is my blue guy. He should have a component called entity on him. Let's take a look and see. Do they have such a component? So the terrain, these are the components over here. This is what you're seeing in the inspector. So all Unity objects have a transform, and then they have some other stuff. Terrain has a terrain component and a terrain collider component. A blue guy, though, has, okay, a transform, but then an entity component, which as you see is a script. And then it also has something else. It has a capsule collider that has to do with physics and movement. I'm not sure we absolutely need that, but we have it. Okay, so this says get the entity component. It's a script. Okay, so since it's a script, it's a bunch of code, and so no surprise it has some methods, and one of its methods is set goal. I set its goal to be the particular place I clicked. That's how I communicate with the blue guy and say go there. Okay? That's that. That's the whole interface code. Okay, now the entity code, let's take a look at that. Okay, so here's the entity code. Let's actually, this is longer, okay? So this has got the whole combat model. It's got its simple movement, okay? Let's start with that thing. What was the call we just saw? Set goal? Let's see if we can find set goal. Well, actually, you can come here and you can right click and you can say, go to definition, and I'll bet I'll find it. There it is, okay? Entity set goal, okay? So you see it's just got a goal property and it gets handed a vector and it sets the goal to be that vector, a vector, x, y, z, right, vector 3. Okay? All right. Now, the entity, again, has got a lot of stuff inside of him, got a lot of parameters. I do want to just kind of talk through, this is going to take a lot longer than I figured on. Do want to just at least say a couple words about these things so it's not magical, okay? Some of this stuff is going to be just fine. You're not going to touch it the whole time, but this is a file you have to mess with, so I want to avoid having it be too magical. So I've got a parameter called close enough. I'm not even sure I'm using that. Maybe I am. That was my check. I use that in checks to see if I command them to move to a location, I don't require them to get exactly mathematically to that location. If they're within this number of units, so a unit is typically a meter, so that's 1 times 10 to the minus 3, so that's 1,000th of a meter, okay? So that's a 1/10 of a centimeter. That's a millimeter from the if you're a millimeter from where I said to go, I'm good. You got there. Another weird thing, to me at least still, is that you have to put F on the back of floating point numbers to tell Unity it's a floating point number instead of a double. You leave it off, it thinks it's a double, and then it will complain because you've used a double where you should have used a float. What other good stuff is here? Okay, the vector 3 for the goal. This is where I want to go as a blue guy. This is where I'm going. I've got a speed. I've got a probability of kill. Every time I shoot is a 1% probability of kill. I've got a tracker to figure out when my next shot should happen. Okay, you can't shoot infinitely fast. Every time you shoot, that time is reset, and we track the time and only let you shoot after the proper amount of time has elapsed. It's somewhat randomized as well. And then here's a range. How far can I shoot? How tall am I? So this is to the top of the blue guy's head is 1 3/4 meters, and then from there down is 12 centimeters to where their eye is, from the top of their head on down, just for figuring out what an enemy can see. Okay, I'm not even sure I use all that detail all the time. And then you can obviously figure out how high the eyes are by subtracting the two. Here's your min and max shot interval. There's not a huge variation between 2/10 and 3/10 of a second. There probably should be a lot more. Okay, and then some stuff, shot color, because the blue guy shoots a blue line out, and the red guy shoots a red line out. Okay. All right. So let's see this. Let's see what I can get to in 5 minutes. Let's try to I'll try to hit the high points, and then we'll take a break, and then I'll pick up again the second hour. All right. So this is the thing that runs when the thing is born. You want to know the blue guy should be targeting red guys, right? So this shouldn't be this should be a little bit self-explanatory. Shot color. Ground clamping just means figure out where the ground is. So if you have terrain, it goes up and down. You don't want the guy to still move in a plane and walk into the side of a hill or float over the valley. You want him to actually track the terrain. That's what that's about. Update is what happens routinely every time a new frame is going to be drawn. Okay, so what happens is target is a variable, is a field that holds the game object I'm shooting at, if there is one. Otherwise, it's going to be null. So that's pretty key. If I have a target, then this is what actually does the drawing. This isn't the combat model. So what happens in update is typically just the visual stuff that you're going to put on to make it pretty for the user. So drawing the guy, drawing the line to indicate that they're shooting. The actual shooting doesn't happen here. Okay? The actual shooting happens in fixed update. Again, what's the difference? Fixed updates happen faster, more regularly, and are used for the most critical parts. Well, if there are any. A lot of games you don't even need to use it at all, but I decided to use it here. So this is the thing that happens. This is an update that happens many times before one picture is put in front of the user. And the logic here is worth knowing. Okay, so just take a look. This is nice and simple. If I don't have a target, I look and see if I can acquire a target. If I still don't have a target, then I move. Right? So I'm only going to move if I don't have a target, and I can't acquire any where I am right now. There's no one around to shoot. Then I'll move. So if you're commanding the thing to move and he's shooting, good luck. He's not going to listen, because if he does have a target, he's going to go and shoot instead. Okay? All right. Now the shooting is less to the point. If I'm going to stick to my 5-minute goal here, let's focus on what you need to do. So searching just basically looks all around. It collects all the units that are around and sees if there's someone you can shoot. You probably know enough to make it through that code on your own if you really care. But we're not going to touch that right at the moment. It's not front and center at least. Let's look at the movement. Okay, so what happens when we move? I don't have a target. I'm not shooting at anybody. So I do have if I have a goal, actually the entities I think are set up so that they always have a goal. The goal might just be where they're standing. Okay? So what they do is look at Y only. So what am I talking about there? So for Unity, so here's actually there's a couple weird things I need to apprise you newer Unity people on. So first thing is, so we use vectors for positions, right? It's almost always up to this point, you've probably seen right-handed coordinate systems, X, Y, Z, thumb, forefinger, middle finger, X, Y, Z. This is a left-handed coordinate system, X, Y, Z. Same idea, but on the left hand. It's not the same. No way to munge one into the other. The next thing to say is that it's Y that's up. So normally in science, we take Z up and X and Y in the plane. In graphics, we take Y up and X and Z in the plane. Okay? All right. So look at Y only now. What does that mean? What it means is I want you to turn to face the target, but I don't want you tilting back. You turn, but only in the Y-axis. That's the meaning of it. And you can go and see, there it is. That's how you actually do that in Unity. That's not really our point right now. Okay, but that's the point of it. So if I'm going to move, I don't want to be sliding sideways. I want to orient toward my, my goal. Then I figure out how much I'm allowed to move. So this time.fixed delta time tells you how long it's been since the last time a fixed update occurred. Okay, that's usually 0.02 seconds, exactly 0.02 seconds. Multiply that by speed, well, that tells me how many meters I can move since the last frame. Okay, and then this line over here, move towards, just takes your current position and it moves you toward the goal, the amount you're allowed to move toward the goal. Okay, ground clamp to make sure you're not floating over the valley or walking into the side of the hill. And that's really it. Okay? All right, so that's what you have to use to get to the objectives of the lab. So obviously, I would say, obviously the most direct way to do it is to mess with the goal. So the goal, it won't just be that the goal only changes when the user clicks, like in my code. And it's going to be more complicated than that, because now we're going to click, we're going to get a whole path. He can move, my goal should be the first waypoint in the path, and then the second waypoint in the path, and on and on. Okay, that's where your work begins. All right? All right, so I think that's good in terms of a lab brief. If you're good to go, that's great. You're on your own, but if you want to spend more time with me on this pleasant Friday, in 5 minutes or so, I'll start up and start basically doing what I suggest that you do regardless. Even if you want to go do it on your own, it's fine. But it's just a basic scenario, the very basic stuff of getting the ASAR Pathfinder project code working. Okay?
Are you able to do like breakpoints and stuff during your
breakpoints are usually not a thing in game programming. It's not a system that's very amenable to that, right?
So the code just has to be good to go.
Well, no. I mean, you do like debug. You can throw exceptions. You can do debug logging. You can certainly pause the simulation to because you're like, oh, my messages are scrolling by. I need to read it. There's a pause button right here.
Okay.
Right. So that's normally how you do it.
That button that's next to it.
I don't actually. Yeah, there is a step there, but I'm actually not sure what that's used for. Yeah, good point. Yeah, I've never actually used that. You made me curious now. I'm just ignoring it.
Oh, yeah, I've been doing that.
All right.
I totally trying to go over stuff. I went back and
Okay, that's fine then. Then you should be sitting in front. Why not?
Presentation. As soon as I did this, I added that extra 3